Dear students, for today we'll see what do you mean by phase locked loop, that is PLL, in analog electronic circuits. So here our topic will be phase locked loop, PLL. Now before going to study what is PLL, we will see the main block which is used in PLL, which is called as voltage controlled oscillator, or it is also called as voltage to frequency converter. So what is this voltage to frequency converter? A voltage to frequency converter, or it is also called as voltage control oscillator, VCO, is an oscillator circuit in which the frequency of oscillations, that means the output frequency of oscillations, can be controlled by an externally applied voltage. Whenever you apply a voltage to it, its output frequency can be controlled or it can be varied. The commonly used voltage control oscillator IC is NE566. So here, if you go to the detailed explanation of what is VCO or voltage to frequency converter, it says that VCO is a circuit that provides a varying output signal. That output signal can be a square wave or a triangular waveform, whose frequency can be adjusted over a range controlled by an externally applied DC voltage. So depending upon what DC voltage externally you are going to apply to this circuit, its frequency at the output will be decided. The VCO provides a linear relationship between the applied voltage and the oscillation frequency. The applied voltage is called as control voltage, VC. The control of frequency with the help of control voltage is known as voltage to frequency conversion. This process where you have an input voltage as DC voltage and output as a frequency, then it can be called as a voltage to frequency converter. Hence, VCO is otherwise known as voltage to frequency converter. This is the theory behind VCO. So here you can see a circuit of voltage control oscillator using IC566. It is a 8-pin IC, and here you can see your pin number 1, pin number 7, pin number 5, pin number 6, pin number 8, pin number 4, and pin number 3. Okay. Now here the input control voltage is given from here. Say this is a capacitor C, and here you are going to give the input control voltage, VC. Okay. So as you give this input control voltage to pin number 5, okay, the output which is going to come at pin number 4 as a triangular wave and pin number 3 as a square wave, the output frequency will vary. The output frequency will vary. Now this frequency depends upon R1 C1, that is whatever you have connected to pin number 6 here, R1, and whatever you have connected to pin number 7, C1. R1 C1 is a time constant, which will decide the output frequency. It's a time constant which will decide the output frequency. Similarly, here you are going to use one more R capacitor C2, this one, which will avoid oscillations whenever the VCO is switching. Then you have here a resistance R2 and R3, which is a voltage divider network, which will decide how much should be the voltage VC applied to the input point 5. So that will decide your control voltage. That means now whatever control voltage we are applying here, okay, now that control voltage will decide the output frequency here. Okay, that means it is a voltage to frequency converter. Now this figure which we have seen now, it is a voltage to frequency converter using IC NE566. The control pin number 5 must be biased externally with a voltage VC. The voltage VC, that is the control voltage, is set by the voltage divider formed with R2 and R3. The output frequency can be made variable by placing a potentiometer in the voltage divider. The output frequency is given by the formula. So here we have shown a formula. So here it is the output frequency F naught is equal to 2 upon R1 C1. R1 C1 where the R and C which we have connected in the external circuit. So that will decide the time constant. And V plus is the supply voltage given to the uh, voltage control oscillator. And Vc is the control voltage which you are going to give at the input. And V plus again is the same supply voltage. So it is V plus minus Vc upon V plus. So F naught is equal to 2 upon R1 C1 into V plus minus Vc upon V plus. If you use this formula and use the values of R1 and C1, supply voltage V plus and control voltage Vc, then you will get what is the output frequency for the output waves which come out of the voltage control oscillator. Now IC 566 contains a circuitry to generate both square wave and triangular wave whose frequency is set by an external resistor and capacitor and then varied by an applied DC voltage. Now after knowing what is VCO, we'll go to see what is a phased lock loop. So here you can see a phased lock loop. So here you can have a input to this phased lock loop. And the first block in this phased lock loop is the phase detector. Now this phase detector is going to compare the phase of this input signal frequency, which is this input phase, and the phase of the output, which you're going to take as a feedback from here. So the phase of the output, which you're going to take as a feedback from here. So here you can see this will be your output signal F out, which will have a phase output. Okay, phase output, phase output. Now, this phase and this phase, the input phase and the output phase will be compared by the phase detector. And depending upon what is the difference between the input and output phase, because the output will be a different as compared to the input, and we want to make the output same as the input. So to make that output same as the input, then the difference between whatever existing output we are getting, that will be converted. The difference in both the phases will be converted into a voltage here. This will be our control voltage. That control voltage will be passed through an active low pass filter, where low pass filter will eliminate the high frequency components, and because it is active, it will also amplify the control voltage. That control voltage is given to the input of the voltage control oscillator. Like for example, if you use IC 566, the input will be given to pin number 5, and then the output frequency here will be decided. Okay, so initially when no input is given, it is in a free running mode, phased loop clock. And when you give a input, then it starts hunting to become same as the input frequency. The output frequency starts hunting to become the same as the input frequency. So this mode will be called as capturing mode. And once you reach to that output frequency, then the PLL locks that output frequency, which is equal to the input frequency. So there will be the locking phase of your PLL. That is where you lock for a particular desired frequency. Then if you go to see the explanation, PLL consists of the following three blocks: phase detector, active low pass filter, and voltage control oscillator. As I've told you earlier, phase detector is a unit which produces a DC voltage which is proportional to the phase difference between the input signal having frequency F in and feedback output signal having frequency F out. Then active low pass filter is one which produces a DC voltage at its output after eliminating the high frequency component present in the output of the phase detector. It also amplifies the signal. Then you have voltage control oscillator VCO. A VCO produces a signal having a certain frequency. When there is no input applied to it, this frequency can be shifted to either side, means it can be increased or decreased by applying a DC voltage to it. Therefore, the frequency deviation is directly proportional to the DC voltage present at the output of a low pass filter. So this is how the construction explanation of PLL is. Then if you go to see the operation of PLL, it operates in three modes. One is free running mode, second is capture mode, and third is lock mode. If you see these three modes, then when the PLL operates in free running mode, when there is no input applied to it, or when there is no input frequency applied to it, it is in free running mode. But when you apply the input, as we have seen in point number 2 here, when you apply input having some frequency, Then the output signal frequency of VCO will start to change. At this stage, the PLL is said to be operating in capture mode. Then number three, the output signal frequency of VCO will change continuously until it is equal to the input signal frequency. Now it is said to be PLL is in lock mode. Once the output frequency becomes equal to the input desired frequency, then the PLL locks that frequency and it is called as locked mode. Then we'll go to say applications of PLL. Applications of PLL says that it can be used in frequency modulation, FM stereo decoders, FM demodulation network for FM operation. It can be used in frequency synthesis that provides multiple of a reference signal frequency. It can be used in motor speed controls or tracking filters. It can be used in frequency shift keying FSK decodes for demodulation carrier frequencies. So these were some of the applications of PLL. Thank you, students.